We're just trying to get YouTube chat in a dock. Got it. Here we go. Welcome to Made Up Wires. We're decompiling a PC version of Mega Race. Kind of an odd history with that game. I did not have a PC growing up. I had an Apple II for a long time. It wasn't until maybe 1996 or so I had access to a PC, but a friend of mine down the street had PCs all the time, and that was one of the games that he had, and I had played it on the Sega CD, and it was interesting to see that crossover in the FMV genre. Oh, sorry, am I? Well, so we're decompiling Castlevania Symphony of the Night, and you can go to soap.c.dev to learn more about that. Something interesting showed up in my YouTube stream yesterday, which was something we talked about last week. One of the YouTube comments was, what would I like to see come out of this project? And one of the things that I thought would be cool to see was the randomizer built into the game itself, and it looks like Mozilla may have done just that. You can go to Dragon Blitz Daily, and it was his video yesterday. Goes through and not the audio, but the way that the randomizer works is it can't just choose any random value for a seed. You have to it's in a way kind of like a cryptocurrency. You generate a random seed value, and then it generates thank you, Dig Down Deep. I had the microphone in the wrong position. I had pushed it aside. So the randomizer generates a random seed, and then it has to do some validation to ensure that the values that would be produced by that random seed are actually valid. And it does that by understanding the position of the elements in the game and what abilities you need to be able to get to first to get to other elements. So if you don't have double jump, if you don't have flight or some other vertical movement, there's certain areas of the game that are blocked off to you. If you don't have power of mist, you can't go through certain areas, etc. We saw that a few months ago. We were looking at the library, and you can get, if you can do the drop kick jump to get up to the area where you're supposed to have some double jump or flight ability to normally get to, you get soft locked down in the not lesser demon. What is the guy down there? Anyway, can't remember the boss's name. Mini boss in that area. All right, so very cool. I don't know what that randomizer is based off of, if it is based off any of the decomp project or not, but pretty cool to see that there. Other project updates. I like using the duplicates report, and it's something that I've featured quite a bit on this channel. But when the build switched from Make to Ninja a couple months ago, the targets that are used to force symbols that we have in C into the assembly so that this report works, all of those broke. And sometimes you do see them. These are cases where the symbols haven't been removed from the static symbol tables. And so you still continue to get symbols in there, or there are cases where the symbol is in the symbol table and the function hasn't been decompiled yet. So we can look at a few of those, see what falses we still have in here. So yeah, so this broke, and I spent some time on Friday, and then it turned into something all through the weekend, trying to fix exactly that. And I didn't want it to be the same, work the same way that it used to work. So previously, when you would force symbols into the assembly, the symbols would get dumped from the ELF file. They would overwrite all of the symbol tables in the config directory, which is something that's checked in, and then redump all of the assembly. And so what you were left with was a dirty config directory. And if you had any changes in there, well, screw you. Those changes are gone. They were all overwritten. That sucked. I was bit by that more than a few times. We have a lot of other tooling that forces those symbols in place. And every time it happens, basically, you get screwed over if you have anything in that tree. So I don't want that to happen. I really dislike, more than Python, I dislike when projects muddy the working tree with build files. And that was definitely one of those cases. And so I have a PR out now, which took me a few iterations to get right because I didn't realize all the different places that it touched. But this now writes only the dynamic symbols to the build directory, get rid of all of this duplicated list of things in the make file, which is nice. A bunch of this stuff got to go away as well. We have a reports target now where you can generate all the reports. And the reports, they no longer get written to your working directory either. They get written to the build directory. So all in all, very nice. And hopefully that'll be in soon. And we'll get symbols in that report again, which is nice. There's another similar thing that I want to do in this in the same vein. If you look at our Splat config, we'll go to Richter's Splat config. Splat generates 2 files, and eventually you use these files to link when you're linking in the assembly, which doesn't necessarily have all of the symbol location information. So this undefined funcs and undefined sims, those get generated, and those are getting written to config as well. I would love to move those to build US config. And what that would do is, yet again, another thing that no longer would write to the config directory. And so cleaning doesn't have to worry about what's there. So it'll get there. Not there yet, but it's something that will get there. Before we get going on Richter, there's a few other things. Always looking to clean things as much as possible. There's 2 warnings I want to get rid of. 3 if you count this collect one related to Richter specifically. The first one should be relatively easy. There is a declaration of a function that has a different signature than the implementation. So we'll look at that. So there's a couple things that I think are worth doing correctly here, because they go beyond just Symphony of the Night, and they're valuable outside of this project as well. And so this first one is looking at the headers for SDK functions and making sure those match the documentation, or if we have the header, making sure it matches the header from the SDK as well. And so to me, that means using the same types and the same notation that they use, not using, like for int, for example, using just the int type directly as opposed to sign 32 or something like that. So I don't think I have this shared, but I could pull it into Safari, I guess. I have to find. So this is the libref, which is where all of the functions are documented. And so we want to look and basically make sure that our function signature looks the same. And this is actually a little interesting because it's not what we would expect. So the signature that we're given says that this returns a long, takes a long ID, and then takes a format string following it. This is not what how this function actually looks. Or at least that's not the way that we've treated it so far. So that's in main PS X SDK, and then libgpu font.c. Let me turn off. I was trying to set up a language server, but I didn't like how it turned out, so I'm going to turn that off. Start over. All right. So our signature here is long ID followed by var args, and that's really how it should be written. I would probably go one further and say that it should have a format string, but actually it can't have a format string because the implementation doesn't allow it. It starts with var args. Does it? Yeah. So we can't even. Oh, camera froze, of course. What's new? Thank you for that, Cristiano. There we go. I switched where the camera was plugged in. Now I know why I plugged it into a different place. Going through the monitor and then back to my computer, as opposed to just going right to my normal breakout box. Anyway, we have to have the signature written this way. So, do we? Yeah, we do. We could actually put a char star here. It wouldn't make that much of a difference. We'll still get the warning. And it still doesn't match the documentation, but it's a better representation of what this looks like. And because this is included everywhere, oh, interesting. There must be some cases where font print is just being called with an ID, so we can't even do that. So odd that the documentation would write it that way, but anyway, not terribly important. The other one is this clamp function. We have this defined two different places, both in the same file. No, one's coming from common. I want to look to see if anybody else is using clamp. when possible, I do like to clean up these compiler warnings. And what I want to see is the implementation the same? It is. And this is just making sure one more time. I think it's the same. This is internal to the implementation. Anything that's internal to the SDK implementation, I'm not as concerned about. It would be nice if these had more portable types. And I think it's less critical that that these are bound to specific widths, because really the target for most of these is just going to be back to the PlayStation. And so we know what the compilers are going to do with those, but took care of that as well. All right, so now we can get back to Richter. I did not look at Richter at all over the weekend, so pardon me. We'll get back through it and see if we can figure out these last few things. So we were relatively close on the PSP, less close on the PlayStation. And so what we're looking to do is fix this condition here on 38. Hey, OTMBN 90, good to have you. How much do we, Dig Down Deep says, how much do we trust the docs to be correct? I mean, the docs are what were given the devs, and so that's the reference they would have had, but they would have had the header files as well. And actually, let's do that. Let's, do I have the header files? I don't have them here. Where do I have them? I do have the header files. Let me see if I can. I don't know if I can show them on the screen, but I will let you know. Give me 1 second. That was in libgpu.h. Yeah, so the function signature that they were given actually is not what was in the docs at all. It was just an ellipsis. So there's nothing in there at all, which is crazy. And it's also possible that they their headers didn't match, and since they were shipping libs that had all of the linking information, but not the source code, the devs didn't need to know that it didn't match, and so that they wouldn't have gotten compiler warnings or anything like that. But yeah, that's kind of interesting. Good question, Dig Down Deep. There are different versions of the docs, and so I'm looking specifically at the SciQ 3.5 docs, which is what Soten was based off of. Dizix says, if I remember correctly, you have one func PSP EU where it should be US, etc. Yes. The match percentage, the symbols will be wrong, and I know that for the PSP, these will all be wrong. And it will be like that throughout, not a concern. And it will affect the match percentage in decomp.me, but it won't affect matching. It's more the registers and things like that. If I only have blue errors and they're only eyes in this gutter, we're good. It's everything else that matters. Even over here on the PlayStation, if we have things like this where we have a constant or a automatic global versus a symbol plus an offset, no issue. It will affect the percentage, and except for the simplest functions or functions that only use the same names in their globals, we'll never get 100% match in decomp.me. That's okay. Not a concern. All right, so I'm going to come back here and look at this 38 again. Not having the symbol names is not ideal, but also not the worst. What I think mostly concerned about is, do we have the ordering here right? And are we potentially loading some of these outside of this condition, or outside of the Boolean expression first? And that would affect ordering. So the PSP, again, it's not optimized. That's specific to Symphony of the Night overlays. If you look at the game engine, that is optimized. But the stages and everything else, they didn't turn optimization on. So we get a very linear set of assignments and instructions. And you know that by the end of this line, for example, by the time you hit the semicolon, every instruction to complete this assignment, along with everything else in the expression, should have been done. So when we come down to this next line, we have to figure out what is this C74C on the PSP versus whatever we have over here, and can we tell whether or not we're loading GRIC first, second, whatever. This strikes me as potentially backwards. We can try that. There's a couple things to poke around there, and yeah, that did seem to work. Not sure if that ordering is correct, but we get a better sense there, and it's possible that this one actually is backwards too. Yeah, I wonder what... so those are correct. It could be types here that are causing that. Let's look at M2C. So we have other instances where we have unknown 6C. No, we don't. Or unknown 6A. No. Right. That would help us kind of definitively know what that is. But let's see how the PlayStation likes that. No different there. I'm going to flip these around as well. No, I need them in this order. So we're loading the tile map. There is this Richter position. It's possible that's being pulled out into a variable. Let's go back. If it's a commonly used function, Zizek is saying, if it's a commonly used function, it might be optimized differently, or might not be optimized the same way. And that's the whole thing. On the PSP, there is no optimization, and so we don't have to worry about that. If this was, I don't think I've seen cases where, and you have to remember, this is old GCC compilers. They were doing some tricks, but they're not doing the same tricks. Most of the time, they didn't have enough context to know whether or not a function that they were calling had side effects that could be optimized in a certain way. And the JAL instruction allows you to jump up to 24 bits away. So there's no need to like throw the address in a register to avoid doing like the math to get at the whole address space. I mean, the address space is bigger than 24 bits, but it's actually 26. How many bits do we have? We at least have 26 bits. Not terribly important how many bits. We can always jump to any function without having to do additional math. So there's not a lot of area for optimizing function calls. The other globals, though, can be optimized if the compiler knows that there's no side effect that would modify them. And we do see that in GCC. And then on top of that, what type of access we're using, like are we treating it as an array and potentially calculating offsets from that address, or a struct where we know offsets as well. Those can cause the compiler to do that differently, but not so much with function calls. All right, so getting back to here, so the V1 A1 issue is an issue. What's happening, basically, we have some additional registers, and how those get chosen really is around, or often is related to how comparisons are done. And so, unfortunately, I think I'm going to have to go through and look at a bunch of these comparisons and see if we can tweak those at all. Oh, this is interesting. So here's a 1E here, which may be a different value. Sometimes when we use less than versus less than equals, different registers get chosen. I don't know why that is the case, but it does happen. And sometimes that's all there is to differentiate. There's some other tricks that we can do, and if I can't figure some of this out, I may just move on. Some of these may have function signatures, so having those function signatures available to us may help. So let's do that. I think we look at this one already. A14. Let's try making this a sine 16. Doesn't change anything. The other thing is, MetroWorks will treat this differently if it's inlined. Not inlined, if it's static. That is one area that we know will change things. And so we do see a slightly different decomp. Part of that is because we have some additional instructions up here. Let's look at some of these lines. What I want to see is, are we... avoiding writing to the V0 register or moving that around. I mean, it doesn't seem to be the case. I throw in no, still not getting what I want. All right, let's keep looking for functions and see if there's other ones that maybe... Oh, back to font print. I think that signature should be in here. It is. This is the wrong signature. It actually is not. This is how it's used. We just talked all about getting that signature correct. So this should be long ID, but it's not actually used that way. And the Sony header would look like this. I haven't seen that cause an issue on the PSP though. I'm not sure what's causing those additional moves. Oh, we could have the opposite problem. Yep, thank you, Dizik. The opposite problem is that it's not defined, and we're using the default signature of the function, which in C is return an int and take all int size parameters, as many as you want. 65, we have a small issue there. That one's easy to fix, but it gives us some register issues. That's just no direct comparison against 0. I want to see if we have any of these other ones like that. There are a few things around returns. The original version had a bunch of returns that I turned into breaks. I do want to go back and look at... There was one more move in here. So, except for those moves and registers, this is looking reasonable. I'm a little surprised at the PlayStation version not being closer. Let's do this. Let's go look for Doppelganger. And I'm not expecting this to be exactly the same, but I do think it will be similar. So the first thing that really differs, there's some status checks above. Those aren't being done. But then there are, after player distance X, there are some additional checks here as well. Before we get down to setting the think step. And it's very similar progression. There's not a lot of returns here either. Oh, I do have some cases where I do have a return on the Richter side. I don't recall this being particularly difficult when I went through it for Doppelganger. And that is the fun of all of this, isn't it? You never know what's going to be tricky. Hey, Powell. So there's some things you have to be careful about. I'm not a lawyer. I'm definitely not your lawyer. And so the question on YouTube comments was working on decompiling a Game Boy Advance game, wondering about the legality of it, and doesn't want his passion project to land him in hot water. Who does? That would suck. So some of it depends on what country you're in and what the laws and copyright rules are in your particular country. Being in the US, we have a lot of legal precedent that says reverse engineering, and the things that go into decompiling are fair use of something that you own. I own many copies of Symphony of the Night, and those are the ones that I work on. So make sure you own the game. Don't decompile from ROMs that you get from unknown places. You have to the code that you produce, or the things that you produce and share with other people, have to be creative expressions, and that's kind of the big thing. And one of the reasons that I don't even want to look or touch anything related to AI related to this. That could M2C and some of the other decompiling tools produce better output? Sure, but if those tools do all of the work, that's a mechanical transformation at that point, and it no longer is a creative expression, and so that's not allowed as well. And then there's assets in the game that if we change them, like if we took all the sprites and made new sprites and said, here, we're going to distribute this like free Soten, but none of the sprites are the same, that probably would be fine. None of the sprites, none of the sounds, that's probably all okay. But if you get into, you can't distribute any of those assets that are in the game. You can only distribute the things that you create. It doesn't matter that it compiles back to exactly the same thing. This is not Konami's code. This is code that we as a group have created ourselves. These are our variable names. We're Ship of Theseus, like projects like this are so far completely legal. Again, I'm not a lawyer. I'm not your lawyer. Do not take this as legal advice. This is kind of my own opinion on the matter. The other thing that we have kind of supporting that position is Nintendo is the most litigious and most proactive company that goes against projects. Like, we'll fight projects, we'll take down projects, we'll sue people for projects that infringe on their IP. And the first major matching decompilation that I was aware of is the Mario 64 decompilation project. And Nintendo did go after that project, but it was because they were distributing recompiled binaries for different platforms, and those binaries had game assets in them. It had sounds and art and other things like that. And so the Mario 64 Decompilation project took down those precompiled binaries, and it still exists on GitHub to this day. Nintendo has never asked for that project to be taken down. And if they're not going to do it, then we don't have to worry about it too much. If they have debug symbols, does it matter? I don't think it matters too much. So debug symbols are going to define globals and function names. And if you go back to like SCO versus IBM and SCO versus who else did they sue big time? Novell. Courts decided there that headers were necessary for interoperability, and those names were necessary to be able to integrate things together. It wouldn't work if you didn't know the names and the interfaces, and so that headers themselves were not copyrightable. Again, is it who wants to be on which side of that lawsuit? I don't think there's any issue with symbol names if they're published out there. It's a list of facts, and you can't copyright a list of facts. And what I mean by the variable names within a function, so we know we might know the names of the arguments of the function, we might know the names of the functions themselves, but everything inside the function is completely original. We don't have the code to look at to create ours. We just have the binaries, and so we have names that may or may not make sense. They some of the names may be exactly what Konami used. We don't know. We have no way of knowing. So we can't be faulted for accidentally choosing the same name, unless somebody finds like piles of CDs with Konami backups on them next to us while we're doing this. Yeah, US law is complicated, and in like 99 out of 100 cases, something like this would like destroy normal people and in favor of companies. And for whatever reason, part of it I think probably was getting a leg up in manufacturing and industrialization and not kind of hindering the growth of the country. But in this day and age, it's still kind of crazy that we can do this here. This is not the case in all countries. So if you're in a different country, none of this matters. So unfortunately, I feel a little stuck on this. And there's a few things that I could play around with and tweak it. It might be worth putting this in the permuter. One thing that I am going to try to do is we have these little tricks that the compiler will do random things for us based on what we put in that may or may not be related to the actual code. I think I'm going to shelve this for now and move on to something else. And I'm going to go do this the way that I typically do, which is looking in the non-matchings folder for all the assembly files. And then doing a sort by size. And then we will pick something somewhere in the middle. Oh, I have all this nice nice fixes to the dupes report. The dupes report actually runs relatively quick. So we were working on Richter thinking. That is one of the bigger functions here. Not the biggest, but one of the bigger ones. And I think that we found the caller of Richter thinking. Was there any other functions called in here that we should be concerned about? We have this one that basically sets the step. Let's go back to, we have this other one, F10. Looks like that one. Oh, that's... I do have a PSP function randomly in there. That's kind of funny. There are places where oh, that actually helped a lot. Is that it? That was it. Oh my goodness. Is that what you're trying to tell me, Dizik? I might be an idiot. Won't be the first time. Thank you. Thank you. So, yeah, the PlayStation version then is pretty close. These, I switched these comparisons around, but they are not correct that way. So let's get those back to the right order. They produce slightly better code on the PSP, but PSP is only secondary. So we have something close here. The what I'm somewhat concerned about, going back to are we really doing this twice? Yes. So what I was saying before, with the non-optimized PSP, if we do something like this where we're subtracting the Richter position, oh, this is pos Y. What am I doing here? What am I doing here? Maybe we'll get this on the PlayStation yet. That might have been it. So we do have some differences. On 51 here, this constant is different. There may be legitimate differences between the two implementations, more than just like dead code. So just immediates. So two small mistakes, and I have the OVL export wrong. I'll fix that. All right, let's see if it compiles. Thank you. Sorry for missing the intent of those comments. Right, so we have a type difference. The type difference is not as big of a deal on the PlayStation, but may affect the PSP. So I am gonna. Oh, it actually affects the PlayStation here quite a bit. So I'm gonna undo this and make sure that this still works with this variable as a sine 32 instead of a unsine 32. It does, so that's good. So the type stayed the same, so I don't have to go back to the PSP. And it worked. Well, that's nice. So this is, yeah, not matching on PSP. That's fine. That's not my focus. Other people are focusing on the PSP, but I am not. So I'm okay with that. I do like to go back and cross-reference these. So if I come back later, or somebody else comes back later to look at this, and I will call this the right name as well. I'm going to leave this PSP name up here. Should I? Let's do this. Let's put it down here. We want some way of knowing what the offset is later if we come back through. Yeah, thank you again, Disick. Appreciate it. Oh, and frozen camera. I can't have nice things. Let's see if we can get that to work. There we go. Guest 73, what do you think about decompiling code with modern features and optimizations, generics, inlining? Yes, very much so. So I talked about this a lot already with the PSP. The PSP overlays are all compiled with no optimization. And so if we compile them with optimization, what is gonna, like, how much differently would the game run? And we do have modern compilers. Do we have modern compilers that can compile 32-bit MIPS? I don't know about that, but getting one of the higher optimization levels seems like it would be an interesting idea. And building a non-matching version of Soten would be good. All right, let's see. So this is the main entity entry point for Richter. And I think I will rename this symbol while I'm here. All these dirty Vim swap files that I need to get rid of. And we call this entity Richter then. and make sure there's no other files that are referencing that already. I think init is already imported, so I probably have that one to fix up. And it makes sense that that is the first of the class-specific entities. So we have a couple other entities. We could look at those. I was going to just keep moving down through the other functions in this file. So if there is something that you want to see, or even outside of Richter. So we did this one. I'm happy to look at a few things. So this 50BC is a new one. It's a reasonably large one. So if none of these other ones are done, that is small. Should hopefully go fast. Try that one. So that's the BDO. Yeah, BDO. And then one more. Make it type. There we go. That one's small as well. So let's look at the BDO one and see if we can figure out what that is about. Dead boss. So this looks like one of the terminal cases for Richter. One had a matching name and doppelganger. Okay. We can look here in symbols. If I have a func.us in symbols, that probably was the same name. We could actually look in doppelganger as well. Let me make sure that I didn't screw up my symbol. Yeah, there we go. And let's look at doppelganger. So this B78 function, which is one that we had, oh, and it is completed, I think. Yep. So the BC is going to be the same as what I called entity doppelganger. In doppelganger, not the best name. I should actually rename this entity unknown ID 16. I should rename this entity doppelganger because that follows the naming convention that we use. Whereas what I have as entity doppelganger 10 here is kind of the implementation that an entity normally would have. This is much smaller than they usually are, but this looks like it's the equivalent. And then this AO14 that looks like the same dead boss. So this next one, this BDO function, looks like it's probably similar to that BO4 function. So let's see what we can find about that. And if they are the same, maybe we can share the implementation. So first, let's look at that. And we can kind of flip back and forth. Easier for me than you, but what are we doing? We're setting the current entity, and it looks like a local variable as well, so that's the same. Then we're going from offset 44 to offset 90. We'll have to see if that's the same here. The rest of this, though, does not look the same. So we do end with the same dead boss print at the end, but by checking step instead of status. So it is pretty unique. It'll rhyme, but not repeat. So let's get over and start seeing what we can do. There's a bunch of unknown stuff here. This is going to be likely an entity reference. We have a bunch of noise here that we'll have to work out. It's being called as a function. It may or may not be okay. Oh yeah, so it's this entity update function. We have a bunch of tools. I just ran into this. There's a bunch of tools that get confused by this. But we're just looking up a symbol in an array, and that happens to be a function pointer. So we have a signature called PFN entity update. Yes, and this is going to be an array of those. Some of these others are probably going to be part of GRIC. I'm not going to break them out right now. The entity is part of the entity table. Not worried about that either. I'm going to take these and put them in the context and get a new starting point. And then we'll start. So I'm going to use the same starting preamble, see how close that gets, and if things need to be tweaked, then I'll tweak them. So we're going to have at least one local entity, and yeah, we'll replace var_s0 with entity. The entity 2 is not going to be its own thing. It's also going to be entity. This is something, if you get into decompiling and do this more often, one of the things that you'll see is that different teams have different styles of doing things, and the style of the Konami team was really to minimize local variables. And I don't know if that was like a current state of the art or what exactly, but that is what they did. I don't know that this is going to be at entity ID 44. That is an assumption based on Doppelganger. It's really entity ID 68. And I can spell right. Fix my so most of this did decompile pretty cleanly, but it's obviously a mess, and you wouldn't necessarily want this. Here's where our 44, the hint for the 44 comes from. It's actually probably not in here at all. This happens with GCC's optimizer. The 44 gets put into register S1, and then the optimizer comes through, calculates the offsets, and bakes them in based on the size of the entity, what the starting point of that array was, and it never needs this immediate value 44 because it doesn't have to do the math at runtime. But it gets left in and nothing comes back and cleans it up. Oh, I'm wrong. It's here. I have seen that happen though. These are doing pointer addition. Pointer addition is different in C than other languages. I don't know of anything that works quite the same way. Any other languages. When you do a plus plus on a pointer, it increments it by the size of the element. All right, so let's try to work this out. A couple checks against 0, so we'll do that first. If entity TID equals 0, not equal to 0. Then we have this, actually we can get rid of this whole else. The else is just the step portion of the for loop. And the go to block 10 as well. So if we have an entity ID, we're going to call this entity update function. And where did temp fee 0 come from? I might have gotten rid of that already by accident. So this is the function call here. And then we're updating entity with current entity. It's actually a much simpler version of the doppelganger one. So what I need to see is, temp v0 was the entity ID. And excuse my brackets. I will get to those in a second. Also interesting, this calls update animation directly the DRA version, which is the game engine version, what we call the game engine. And that is quite a bit different. Here we have GCC's logic for doing ranges. This is always a pain. It will add a value here and then do the check for greater than, and I always forget what the order is. I think I have to subtract 20, but it's a range between what, like 121 and 141. We'll see in a second. Let me fix my compiler errors, and then we'll keep going. I'm gonna get rid of all the extra parens. We don't need the mask. All right, where am I missing? That one. So our top is looking pretty good. This will have, yeah, there's some work to be done down here. This flag, we have linting tools that'll come through and clean up all the flags, so I'm not going to do them manually. And we do need to fix the ranges. It's going to be greater than 160, I think. And, or less than 30, negative 32. And then kind of the same thing down here. Uh, 120. Oh no, it's subtraction. I'm subtracting. So we end up getting, take away the equals, that gets us to 110. And then subtracting the 10 that we're adding here gets us to 100, which is the same as 128. Or sorry, hex 100, which is the same as, yeah, 128, right? And this will be 16. So some slight register issues. Did get my 160 wrong. Nope, wrong direction. No, this one ended up being not hex. And so then this is what, 128 plus 32, which is 150. That's what I meant. I meant no, I'm wrong about that too. Not the 128 either. And this should be wise. There we go. Oh, that got us. 100 is 256. Thank you. Oh, these end up being the same. Yep. So this is the same as Doppelganger. All right. So we have that first for loop in place. And what are we doing next? So 7FC is being treated as an unsigned 8. I don't see a lot of... Why are we... Oh, no, we're... The add is really a subtract. So it is a assigned value. Let's get that back out here. M2C can't tell, but we're doing a subtraction here. So this looks like some type of timer. So we do the subtraction, and the subtraction doesn't happen unless the condition holds, and it's just kind of optimized out. And if we're on the a tick, an odd tick, then we're going to do this function call down here. Uh, 40. So this is getting... Now I'm going to go back to... making that unsigned. We're loading it as an unsigned. And I guess the rollover is just fine. So it looks like only one other error down here at 53. And this is, again, going to be a for loop. So our entities here are going to be at starting at entity ID 68. Basically, there's a set of four well-known entities at the start of the stage entity range. And then everything else is dynamically generated. These are all struct access. And so it's a similar loop to what was above. Just going through entities, not updating current entity as we go through. And that should be it. And this is usually what we get then with something where we know most of the globals. We just have a few of these symbols that decomp.me wouldn't be able to resolve. And that one should be done as well. I do need to make sure that I grab all these. Cleaning up some of the types here. What did I screw up? I'm going to make sure that I have the correct entity IDs. So I don't have EID 43 yet. Or 44, I'm sorry. And then there will be a 90 as well. Okay, it didn't match. Oh, bunch of variables. Not terribly important that these unused variables are here, but might as well get rid of them. So something didn't match. Not in a good way. Let's make sure that so this PFN member of the GAPI structure looks like it has been renamed since I did this. Let's do a search in config. So it still has that same name in config. Let's look in it's either going to be in main. A lot of the data that DRA uses is actually allocated in main, the main overlay. So it still has that same symbol. Not super surprising because that's the symbol that is in the is in the symbol table. Oh, camera dead again. Great. You'd think that so it's a Thunderbolt monitor. And with, as far as I know, like a high-speed USB in it. I think all that would just work, but what do you know? All right, so we need to go find what this is. What is my variable? It's GAPI. Game API. And what? What it is? EA5AC. It looks like it was just renamed to Funk. I'm looking for 1611. It's been a while. So this happens, and so what the field was renamed, but the symbol wasn't, and that's okay. My guess is that nobody has run into this. And then that matches. So I am gonna fix this though. This cannot stand. And let's fix it in HD and in US. And I'll submit that as a separate PR. Oh, come on. All right, and let's rebuild all those things. So that is the main symbol table. And when you update the main symbol table, everything else needs to be updated. What time are we at? I think we have time for one more. So I think there's one more in that same area. Sorry. Everything works, nothing's wrong. I need a producer to do my cameras for me. All right, so we're looking for that last function that's not gigantic. And I think it's this 998 function. Yeah, that one's nice and small. Oh, scale cutscene after? That be right? No, that's not. Oh, huge jump table here. Yeah, I think that's reasonable, actually. Let's go back and look at that BBDO. So here's something that's potentially nice. If we have this entity Richter function and now this BBDO function. If there's nothing else that references this BBDO function, we don't have to update a symbol table. And that's one of the nice things about getting more and more compiled. There's less that we have to manage. I need to look in two directories here, one in data and the other non-matchings. BBDO was already exported to non-matchings, so of course it knows its own symbol name. But the only other place is that function. So so what are we doing here? Part of it is Richter being dead. I'm gonna get the flags. Not sure if I'm ready to name it yet. So we're gonna go through basically all the. It seems like it's clearing out any entities that are no longer needed. So it's kind of like a garbage collection function. That's what I'm getting from this part. So this Yeah, and this does tell us that so we can kill Richter. We can kill the Shaft's orb. There must be some other scenario that can be hit. When we get into the big Richter state machine, we'll look at that as well. I haven't looked at some of these other GAPI functions that we don't have names for yet. I'm going to leave the name, though. Oh, did I get rid of the wrong function? Oh no, what did I just do? What? Why would I... What? Sometimes I just push buttons and characters change and then it either works or it doesn't work. Usually not. Usually it doesn't work. Alright. That was weird. Let's get on to this next one. So this looks like a huge jump table. Switch. Huge switch. It doesn't look like there's much else besides switching. Assigning some globals. Our switch is going to be much bigger than this. But we're not doing much here. Maybe our switch isn't. Maybe... I don't know. Alright, let's fix the go-to. Change this to a ++. So we have all of these RO data with all of these values in it. And that makes me think that all of these values are actually represented here. So we're able to get rid of, or the way that it's currently compiled, basically there's no jump table that's necessary. It is quite possible that this has every case listed from 0 to 40. And so I'm trying to regenerate as much of this RO data as possible. That did pretty good to get the general structure of the function. 22, 23. This increment doesn't seem to be there because it there we go. So let's see, 26. Possibly this is a break. Yep. So, yeah, we have every single one of these cases in there. It's going to be, let's 30 times 16, 3 times 16 plus 3. So 51 cases altogether that need to be represented. So somebody who wasn't me at some point wrote this and thought this was a good idea. This may be like the GRIC step. That would make sense to me. So it goes up to 50. So we're not quite, oh, maybe this is simpler than I thought. Let's try to get rid of these. We still get the right jump table. Let's try to get rid of this. Nope. What else can we get? Can we get rid of 12? I can get rid of 12. That works too. About 0. That seems to work and give us the right jump table. We could move all these together. We need the 0, I think. Yeah, we need the 0. And so we have 0 and 50. Okay, that's much better. Oh yeah, is this the thinking step? You could be right, Disick. It's right before the thinking step. Not right before. It is before the thinking step. But it's not part of GRIC either. Do we need all these still? So we do know we have that. Castle flags will tell us a little more, so let's look at castle flags. Shaft orb defeated. Let's see if we've seen either of these yet anywhere else. Not that one. Okay, so we have seen this second one. Also related to the shaft orb. And so I think at some point we'll have to go back through and document the other Richter thinking steps, but this obviously is related to one of them. But we have this one done as well, 998. That felt fine, and my biggest concern with that one was whether or not we were building the same jump table, and it looks like it is. There must be some significance to these particular yeah, it must be an enum of some type. And we just don't know what it is yet. And I think the 11C0 was new. All right, well, that is about my time for today. We got a couple done, which is nice. Appreciate everybody joining. Oh, camera froze. Thank you. Thank you, Christiana. Castle flags, yeah, let me... we call it, again, our names, we call it castle flags. Basically, it's all the things that get tracked. And most of these are things that end up back in the save file as well. So when you have the game eventually on a save, this array gets written out. What's interesting about this is there are a lot of these. We have hex 300, so 256, 512, 768, is that times 3? 768 bytes. Use a ton of space. These could be bit flags, but they are not. So 700, almost a K of data related to different booleans for whether something or not has happened in the game. All right, so that's it. Let's. I didn't show you where that's. Anyway, trust me. Go to soten.z.dev to learn more about the Symphony Night Decompilation project. And I'll be back tomorrow doing more, working on Richter. Breaking things. Getting your help to decompile. Appreciate it. Thanks, Dizzy. Thanks, Cristiano. Dig Down Deep. Yeah, 73. And where is it? Scrolling back. Scroll buffer. Powwow approval. Appreciate it. Good luck on your project, and when you get started, drop by again. Drop us a link. At the beginning, we talked a little bit about randomizer getting built into the game, which is totally sweet. I don't think that there has been a release of this yet, but hopefully we'll see it soon. And then just some other project update related stuff. Not terribly important. Adios. See you tomorrow.